In this video, we will be looking at slope-intercept form using tables. By the end of this lesson, you should be able to graph linear equations in slope-intercept form by evaluating functions and plotting points. Let's take a look at an example. In this problem, it asks us to graph the linear equation, 5x plus 2y equals 6. In the last lesson, we looked at graphing this equation using our x and y intercepts. So let's try that again. So remember, if we wanted to find the x-intercept, this was where y is equal to 0. And I would substitute, I would leave 5x plus 2, substitute y with 0 equals 6. 2 times 0 is 0, plus 5x equals 6. 5x plus 0 is 5x equals 6. Divide both sides by 5. X is equal to 6/5. My x-intercept would be 6/5, 0. Now this is a little tricky to graph on my graph. I get a fraction there, so it's not as easy to solve in this manner. So we have another strategy that we can use to avoid getting fractions to graph these kinds of equations. So another method that we can use is solving for y. So I'm going to take my equation and use my strategies from literal equations to solve for the y variable. So I want to subtract 5x from both sides first. I get 2y equals negative 5x plus 6. Divide both sides by 2. I'm left with y equals negative 5 over 2x plus 6 divided by 2 is 3. Now I've got this equation in y equals negative 5 over 2x plus 3. If I go over to my calculator, I notice that I have a button on my calculator that says y equals. I want to press that so that I can look at the table of values for this equation. So I'm going to type in, I have negative 5 over 2x. So I hit alpha y equals, enter, to get the fraction. Negative 5 over 2x plus 3. There is my equation, and I want to make a table of values. So I'm going to hit second graph. If you notice graph above it, there's a tiny word that says table. Second graph, and I can see here all of the values that would make this equation true. Now I don't want to write all of them, and I just want to look at the ones that are not fractions because I'm going to be plotting points. And it's more difficult to plot fractions. That's why we're not doing our other strategy here. So the first one I see is negative 2, 8. Negative 2 is my x, 8 is my y. Then I have 0, 3. 0 is my x, 3 is my y. Then I have the point 2, negative 2. And lastly, 4, negative 7. Now I'm going to go over to my graph and see which of these points I can plot. So I see negative 2, 8. Well, that kind of goes off my graph. So let me look at the next point. 0, 3. I can plot that. 0, 1, 2, 3. 2, negative 2. I go to the right 2 and down 2. 1, 2. And 4, negative 7 will also go off my graph. So I'm just going to connect these 2 points. And there is my graph. That is the graph of this equation. So for this, if we cannot use our x and y intercepts, the other strategy is to solve for y. Solve for y, and then plug into calculator. putting the equation in this format is known as slope-intercept form. The format for that is y equals mx plus b, where m is my slope and b is the y-intercept. This is the form of the equation we will use when we want to use the calculator. Look at the table. Okay? But we will first have to solve for y sometimes if it's not already in y equals mx plus b. We also use what's called function notation when working with equations in this form. We write this as f of x. It's read f of x. It means the same as y equals, but we use it when we're substituting in values. And it does not always have to be f. Sometimes you can see g of x, you can see h of x, p of x, can really be any letter of x. And we just use this when we want to substitute in values. So let's look back at our equation that we just saw. The directions say evaluate each of the following functions for the given values. So what if we're given specific values? When I say f of x, that means the value in parentheses is my x, and what I get out is my y. So let's take a look at this mathematically. So if I want to know what f of negative 2 is, I will write f of negative 2 in parentheses equals negative 5 over 2. Now instead of writing the x that's here, I'm going to substitute in that negative 2 in for x plus 3. You can go back to your calculator. Remember alpha y equals, enter for a fraction. So I'm going to type in negative 5 over 2. I'm going to type this exact equation in, negative 5 over 2 times negative 2 plus 3. And I get 8. So f of negative 2 equals 8, or the value of y when x is negative 2 is 8. For f of 4, we would do a similar process. F of 4 equals negative 5 over 2. Now instead of writing x, I write my 4 plus 3. Again, I can come over to my calculator. Alpha y equals, enter, negative 5 over 2, parentheses, 4 plus 3. Negative 7 equals negative 7. So the value, I write f of 4 is equal to negative 7. The value of y when x is 4 is negative 7. We can check this by looking at the table of values from our earlier problem. So if you notice, f of negative 2 equals 8, x is negative 2, f of x, or y, was 8. F of 4 is equal to negative 7. When x was 4, y, or f of x, was negative 7. We've reached the end of our video. Please bring your notes to class, and we will finish talking about this and working on more examples together.